Hi guys, hope you're all well. I'm back with another tutorial, and this time, obviously, this is going to be more of a Houdini centric tutorial. The effect that I'm going for this time is sort of where you have concentric rings that morph into something that looks like um, a velocity field or a more geometric shape. I'm just gonna play this play blast so you get a better idea of what I'm talking about. There you go. So you see how we have these ribbons or strings that are sort of morphing into a different shape. Now I've obviously enabled this mask just so that you guys can see better. Okay, let's get started. And so the basic idea of the whole simulation was to like create something which was procedural and which had a lot of ability for you guys to generate different patterns out of. Now, so what I started off with was just a simple grid, and like this was a pretty darn dense grid, as you guys can see over here. And what I ended up doing was I ended up creating an attribute wrangle that sort of generated these patterns for me. And this basically goes off as I think it's Cialdini's plate, where you sort of vibrate a plate at a certain frequency, and it creates those intricate patterns with sand or with salt or whatever it is. Now I link down a very detailed tutorial that talks about how we got to this. But the idea with this was that you can actually generate a lot of different patterns. So as you can see, the more I meddle around with the values, the more different patterns it is that I get. So this I really like the approach for this, and I think it gives you some amazing results. And also another good thing about this was that you can actually animate this and get sort of like an animated morphing sort of a pattern over here. Now, once that was done, what I ended up doing was I just created a very basic fit ramp where I sort of converted that attribute amp that I created, and I turned it into a color attribute and sort of just pushed the values a little closer, right? And what that gave me was a black and white mask. Now you can definitely just use a simple color node to do this as well. I mean, don't have to go through all the fuss of this, but uh, I was actually doing something else, so I ended up doing this. But a simple this node would also like suffice with what I was doing over here, as you can see. Now, once that was done, what I ended up doing was I just blasted out all the black there was. I'll just turn my grid plane off so you can see. So I just blasted my black out, and then I made a group which had the edges selected, right? And I just converted that group into a line, right? So I get got rid of all the geometry that was within this border, right? And then I used a resample node to create to sort of just bring down the point count, because I eventually had to, you know, smooth this out. And after that was done, what I ended up doing was I just gave this some normals, and with that normals, what I could do was that there you go. I could have these tangential normals along the pattern, right? And after that, what I did was that I took the same grid and I scattered some points on top of it. 25,000 points were good for me. And once I had these points scattered, I just transferred that attribute that I created over here. So I didn't create the normal attribute. I actually renamed it to V, which is velocity, and I just transferred that velocity onto these points. So um, if you could see over here, there you go. So you see that velocity over here, and let me just yeah. Now these points sort of had velocity, and once that was done, I just use a simple volume rasterize workflow to convert this V into a volume velocity which is well. Now I'll also plug in a tutorial for how this method works, but it's pretty simple. It's not that difficult, and we could visualize our velocity over here with this. So this is how the velocity field looked like. Yeah, and I mean it looks really interesting, and like I really uh, liked how this came out. And once this was sorted, what I ended up doing was I just took a simple line, right, and I gave it a lot of points, but we'll come back to this later, right? And for now, let's just give it some less points, right? And once that was done, I just resampled this and I made sure the maximum segment length was off, and I created an attribute called curveu, which gave me this, right? So this is basically an attribute which tells that this is the zero and this is one for the whole curve, and it creates a gradient in between them. It's just a float value, right? And after that, I just used a revolve to sort of turn that simple line into concentric circles. I gave it a class attribute and I resampled this with a resample node to add more points. So over here, I think I had about 25,000 points. And once I resampled, I had about about 163,000 points, right? Now, once that was done, what I ended up doing was I ended up using an attribute adjust float just to sort of create a ramp for my curve view attribute. So initially my curve view attribute over here was 0 to 1. Over here what I did was 0, 0 and 1 in the middle, right? That is all that I did. Nothing complicated, nothing fancy, just a simple attribute ramp, right? And once that was done, what I ended up doing was because these was concentric circles and these weren't closed splines, I just used so I just use a fuse node to sort of make sure that they're closed loops, right? Uh, After that, I just gave it a color just to make sure that I can see this better. And once that was done, I basically used a vellum hair node and I didn't do anything on here. Like I didn't change anything except for I think the bend stiffness, but that is just something that you can meddle with. I did not want any stretch on this because I didn't want the strings to be stretching apart. Rather than I wanted them to sort of hold the distance that they were at and bend around it. So that is why I just used a very high stretch stiffness and used a very small bend stiffness. And after that, I went to my Vellum solver and just give it a moment. And I used a pop advect by volumes, right? And I imported that velocity that I created over here, this one, the well, and I imported that into my Vellum simulation through a pop advect by volume, right? And these were the values that worked for me. These are very dependent on scale. So make sure when you're making yours, you have a clear idea of you tweak these values according to your scale actually. And okay, so once this was done, I used a Vellum post process and I used that not to actually engage more subdivisions in there, but to export these extra attributes for my simulation, right? Now, this I think is a little more important to talk about. So over here, as you can see, I have a lot of strings over here, right? And in this simulation, so if I try and run this, I don't know if it's gonna run. Let me just try and run this and see if this works. Yeah, it actually does play through my PC. So over here, as you can see, with the lower number of strings, you don't actually get that detail in between the strings, right? So for that, I actually had to bump my points from 100 to about a 1500, and that took a lot of time. Like that really pushes your computer to the limit. So I'll talk about the workflow, a workaround that I found for that as well. But let's just continue, and I'll come back to that at the end. So I sort of cashed out my whole simulation, and I'll tell you exactly how much this simulation costed me in just a second. Yeah, so this was around 100 GB on 1500 points, right? So I don't know if you have the hardware or the hard drive for that, but yeah, that's what it is. Now, once that was done, what I ended up doing was I remember the attribute that I exported over here as stretch stress. I brought that attribute to an attribute rename and I just renamed it to mask, and this is how that looked. So this was the mask that I got, or the stretch stress, right? After that, I got rid of all the attributes mentioned over here. I didn't need them currently, and once that was done, I again used a connectivity node to, but this time on the primitive level, to sort of separate my strings, like create different separate primitives for the string, so it does not get treated like a single object. And once that was done, what I did was I used a point warp, sorry, and let me just get rid of this. So inside of this point warp, it's not that difficult. I just brought in my p-value. I converted that from vector to float and converted back to float again. Now in the y value, because I wanted to create these bumps, right, where I had the simulation sort of bend the maximum. I wanted those areas to be sort of to sort of create these troughs and crests, like a desert, right? What I did was I brought in that mask that I created from the attribute rename, right? And I added that with my y value, right? And what that did was it gave me these troughs and crests, right? So I had some randomness within my strings. So if you look at this, you'll see that it's not all flat. Like it has that depth to it. So the strings actually have places, and you get those really fine curvature details, right? So that is what I did over here, and you guys are feel free to look into this and play around with this. The file is obviously going to be attached as always. And once that was done, what I ended up doing was I think I used this. Yeah, I just exported that whole thing out as a colored attribute, right? And once that was done, what I ended up doing was I remapped my color attribute to temperature, and that is only because I had to export this to Cinema 4D, and within Cinema 4D, I wanted a vertex map, and temperature works really well, right? Also, another thing to note over here is that I used a random node, right, to give this sort of randomness over here to make sure that each string along this heighted region sort of has a different value, so it adds more randomness to when I'm rendering it rather than being uniform. Otherwise it just looks really boring. So that is what I used over here. I just multiplied this mask with a fit range and a random value to generate this random value to this random pattern over here. Now, once that was done, because this was like a very big simulation, what I ended up doing was I used that class node that I created over there, that class attribute through connectivity that I used over here to delete the outer rims of the whole simulation, so I could render this out, like, so I could export it at a much lower cost, right? And I just used a smooth node over here to smooth this whole look out, so it doesn't look as random as it did before, and just to give it a little bit more uh, finesse. And once that was done, I just used a sweep node. Now this is gonna take a while because this was like heavy. Yeah, I just use a sweep node, right, to convert these into tubes, and I gave it some UVs, and I exported it. And yeah, that was that. Now, coming to the fact where I told you guys that there's actually a really simple way where you can upres all of this with not without sort of simulating the whole thing using very high points. So what I did was, if I take this simple vellum solver and I just give this, wait, where do I have these values going? This and that and this. There you go. So what I do is I just take a simple, just give it a moment. Yeah, what I do is I break down a copy from this line, right? And I just bring this in and resample it over here, right? So I add all the points that I needed over here. So now I have 500 points, and I can bring this down even lower. Yeah, I have 1,000 points now, right? And I could revolve that, right, again and resample it to have even more points. Fuse it, just like the same thing. And I use a point deform to convert my low resolution simulation into a high res one. So if you look over here, see, you've just added more detail in there without using your resources. Now, how does that look different from the actual simulated one? I'll do that. I'll open that as well. So if you come back to frame number 54, anyway, just this is how the simulated one looks, and this is how the point deform one looks. So there's a very minute difference. I don't think there's a lot of difference, but I mean I could afford simulating this. So I mean I've got a good PC, so I could afford simulating this, and so I did. But yeah, that is basically how you simulate this for a lower cost. So I hope you guys like the tutorial today, and please let me know if there's something that does not make sense to you, and I would reach out and explain it further. And please support me and like comment, share, like the video, and I'll be making more tutorials in the future. Thank you. Bye bye, and hope all of you have an amazing day. Ciao.